Let's solve this GATE Computer Science 2024 question. Latest question. A functional dependency f x determines y. Okay, this functional dependency is termed as useful functional dependency if and only if the following three conditions are satisfied: x is not empty, y is not empty, and intersection of x and y is empty. Means they have nothing common. X, y, they have nothing common. For a relation with four attributes, the total number of possible useful functional dependencies. Okay, we need to count. If you have a relation with four attributes, then how many useful functional dependencies are there? So first of all, this understand the definition of useful functional dependency that is given in the question. Okay, useful FD. The question is saying that X determines Y is useful FD. It is a useful FD. Okay, when can I say this is useful FD? If and only if three conditions are given to you. The first condition is that X must be non-empty. Okay, X is non-empty. Y is non-empty. So both are non-empty. Okay, both are non-empty. And the third, that is X intersection Y, that is empty. What it means? It means there is nothing common. It means X, Y, they have nothing common. Okay, so remember, it means X, Y have nothing common. No attribute common. Nothing in common. So this type of FDs are called useful FDs. Okay, for example, if you have relation with four attributes, let's assume this is your relation with four attributes, then tell me which of them are useful FD. First you understand the definition, then you solve the question. So tell me which of them are useful FD. For example, is this useful FD A determining B? Yes, this is a useful FD. You can easily see this is non-empty, this is non-empty, and you can see they have nothing common. Okay, what about this one? Is this useful FD? A determining AB. Is this useful FD? This is not useful FD because this A is common. Okay, you can see LHS, RHS, their intersection is not empty. Okay, in the useful FD, okay, in this useful functional dependency, you can see that X, Y, their intersection is empty. Means X, Y, they have nothing common. Okay, so remember, this is not useful FD. Okay, what about this one? A determining CD. What about this one? Yes, this is useful FD. Correct. Okay. What about this one? ABC determining CD. What about this one? This is not useful because there is C common. Yes or no? There is C common. So this is not useful. Agree? What about this? ABC determining D. Yes, this is useful. Okay. A determining B. This is useful. A determining C. This is useful. A determining BC. This is useful. Okay. And so on. So I hope you understood what is the useful FD. Okay. Very simple. Now tell me, can I put all the attributes on LHS? All the attributes, if I put on LHS, then can I create useful FD? If I put all the attributes on LHS, can I create useful FD? I cannot create. Yes or no? Because remember, if I put all the attributes here, then here I have to put empty set. But remember, this Y cannot be empty. Y is not empty. X is not empty. Okay. So very simple. All the attributes I cannot put on the LHS. Yes or no? Is this clear? So very simple point. Now let's count what is the total number of possible useful FDs for a relation with four attributes. This question we are going to solve by three different methods. Okay, let me tell you all the three methods one by one. So let's see the method number one. This method number one, this is an easy method. Okay, let's see. So remember, you have a relation A, B, C, D. There are four attributes and we need to count how many useful FDs are there. So this is a by case method. Just create the cases. What is the case one? Case one is on LHS, I am putting only one attribute. Yes or no? LHS cardinality is one. This is the case one. Okay, I am putting only one attribute on the LHS. For example, I can put A. If I put A on the LHS, then tell me how many useful FDs I can create. If I put A on the LHS, then remember, for example, I can create this. Okay, I'm just explaining that I can create this FD, I can create. If I put A on the LHS, I can create this, I can create. Okay, I can create BCD, this I can create. I can create CD, A determining CD, A determining BD, this I can create. Yes or no? What else I can create? Tell me. I can create A determining C, A determining D. Only these I can create. Yes or no? Total 7 I can create. Do you agree with me? Okay, nothing else. So if I put on the LHS, if I put A, then only these many I can create. Okay, these 7 I can create, 7 useful FD, UFD. Okay, UFD, useful FD. In short, I'm writing it UFD. Okay, let me write in short, let me write UFD. Okay, so I can say there are 7 UFD of the form. Okay, of which form? A determining something, something, something. Yes or no? Is this clear? There are 7 FDs of this form. You can see. Now, how to find this 7? Okay, from where this 7 is coming? This is actually very simple. Notice one thing, that if I put A on the LHS, then here I can put any subset of BCD. Do you agree with me? See, here I can put any non-empty subset of BCD. Do you agree with me? Tell me. I can put any non-empty subset of BCD. Subset of BCD. Yes or no? Is this clear? Tell me. If I put A on the LHS, then here I can put any non-empty subset of BCD. How many non-empty subsets of BCD are there? Tell me how many non-empty subsets of BCD are there? Okay, there are total 7. Yes or no? 2 power 3 minus 1. This 1 is to remove the empty. Okay, so that means there are 7 choices. Okay, remember this point. See, very simple point. Remember, if you have n elements, if you have, okay, if you have total n attributes, then how many subsets you can create? If you have total n attributes, then remember you can create 2 power n subsets you can create. Okay, in these 2 power n subsets, one of them is empty. One of these is empty. Yes or no? One of these is empty. So I can easily say that from this I can create 2 power n minus 1. These many non-empty subsets I can create. I can create these many non-empty subsets. Okay, is this clear? So remember, if I put A on the LHS, then for the RHS, there are total 7 choices. Yes or no? Similarly, if I put B on the LHS, then for the RHS, how many choices are there? Now here I can put any non-empty subset of ACD. Yes or no? Here what I can put? Remember, here I can put any non-empty subset. Here I can put any non-empty subset of ACD. Okay, so tell me, how many non-empty subsets of ACD are there? Let me know how many choices I have for this RHS. Okay, how many non-empty subset of ACD? That again will be 7 choices. Okay, is this clear? Are you getting my point? So this is the idea. I hope you are getting this idea. So finally, let me write down. So if the cardinality of LHS is 1, okay, means, okay, how many of this type? How many? There are 7 FDs of this type. Yes or no? 7 UFDs, useful FDs. Similarly, if I put B here, then again 7 UFDs. Okay, if I put C here, then again total 7 UFDs. And similarly, if I put D, means on the LHS I am putting 1 attribute. If I put D, then again there will be 7 UFDs. Okay, that's it. So total how many? Okay, in this case, total how many I got? Let me know. In this case number 1. Tell me, in this case number 1, I got total 28. Yes or no? I can say 4 into 7. Okay, there are 4 into 7. So I can say there are basically 28 FDs, UFDs. Yes or no? Useful FDs. So this is your case number 1. We have done the case number 1. What is case number 2? Case number 2, that is on LHS you put 2 attributes. Okay, on LHS I am putting 2 attributes. So tell me, on the LHS, if I put 2 attributes, for example, if I put AB on the LHS, then how many choices are there for this right side? Here what I can put, just tell me this point. AB I am putting on LHS, then on the RHS what I can put? I can put any non-empty subset of CD. Yes or no? I can put any non-empty subset of CD. How many non-empty subsets of CD are there? How many non-empty subsets of CD? That will be 2 power 2 minus 1. That is 3 choices. Yes or no? Okay, that's it. So remember, if I put AB on the LHS, then on the RHS, there are 3 choices. Now you tell me, if I put AC on the LHS, on RHS, how many choices are there? Again, there will be 3 choices. Again, there will be 3 choices. Okay. Similarly, if I put AD on the LHS, then on RHS, again, there are 3 choices. Okay. Again, there are 3 choices. Similarly, okay, like this, you tell me, Like this, what are the cases possible? You can easily see that on the LHS I can put BC on the LHS. Again, there will be three choices. I can put BD on the LHS. Again, there will be three choices. I can put CD on the LHS. Okay, again, there will be three choices. So total how many? That's it. Okay, these are the two attributes I can put on the LHS. So total how many? Tell me in case two. In case two, what answer you got in this case? In this case, I got 6 multiplied by 3. Okay, yes or no? 3 plus 3 plus 3 and so on. So finally, I got 18 useful FDs. Okay. Now, you tell me about the case number 3. In the case number 3, what I will discuss? I will discuss on LHS if you have 3 attributes. Yes or no? Okay. So on LHS, I want to put 3 attributes. For example, if I put ABC on the LHS, then how many choices I have for this RHS? Then only one choice is there. Only D I can put. Yes or no? Agree? Okay. There is only one choice. Okay. Only one choice. That is a D. There is only one choice. That is a D. Okay, that is a D. I can put D. That's it. Yes or no? Very simple. Okay. So remember, on the LHS, if I put 3 attributes, then RHS only has one choice. For example, on LHS, if I put this, then again there will be one choice. On RHS, I have to put C. Okay, there is only one choice. Similarly, on the LHS, if I can, what I can do, I have to put 3 attributes. So I can put ABC, ABD, I can put BCD, I can put ACD. That's it. Okay. So again, one choice, again, one choice. So total how many? Tell me. In this case number 3, I got a total 4 UFDs, useful FDs. Okay. Is this clear? And what is case number 4? Can I put LHS cardinality equal to 4? See, method 1 we are considering. So tell me, this case number 4, this case number 4 means LHS cardinality is 4. Okay, if I put all the 4 attributes on the LHS, then how many useful FDs I can create? No useful FD of this type. Yes or no? 0 useful FDs of this type. Okay, I cannot create any useful FD of this type. Okay, so in this case, 0. So tell me, finally, what is your answer? Total number of useful FDs. How many total number of useful FDs are there? Tell me. That will be in the case number 1, 28. In case number 2, 18. Case number 3, there were 4. Yes or no? So what is the total here? The total will be 50. Is this clear? So this is your method number 1. I hope you understood. See, method number 1 is only for understanding purpose. Now I will show you method number 2. That is very good method. Okay, so far we have seen method number 1. This method number 1, this is for understanding purpose. Okay, yes or no? Correct? This is for understanding. Just understand the question, just understand the solution. This is only for understanding purpose. I told you this method. Now I will tell you method number 2. Okay. Yes, this is a naive method. Okay, this is, I can say, this is very basic, or this is only for understanding purpose. You don't have to apply this method in the gate exam. In the gate exam, you can apply the method number 2. But anyway, this is for understanding purpose. I hope you understood. Tell me, did you understand what is the question, what the question is asking, and what is the answer? Did you understand this method number 1? Everything in this method number 1, did you understand? Let me know. Okay. So now let's see the method number 2. Okay. Now this is very beautiful method that I'm going to tell you. And then I will tell you method number 3 also. Okay. So let's see method number 2. That is RABCD. So this is your relation. Your relation has total 4 attributes. Now in this method number 2, again I will create the cases. Again I will create the cases. The case number 1. On LHS, is it possible I don't put any attribute? Is it possible that on LHS I don't put any attribute? That is not possible, because useful FD says that LHS must be non-empty, RHS must be non-empty, and they should not have anything in common. Okay, so remember, okay, case number 1, that is LHS cardinality equal to 1. Okay, this is your case number 1. So remember, on LHS, only one attribute I can put. One attribute I can put here. Okay. For example, I can put A or B or C or D. Yes or no? I can put one attribute here. Remember, here I have to put one attribute. And here I can put any non-empty subset from the remaining attributes. Yes or no? Here I can put any non-empty subset, any non-empty subset of remaining three attributes, remaining three attributes. Do you agree? On LHS, if I'm putting A, then here I can put any non-empty subset of the remaining three attributes BCD. If I put on the LHS, if I put B, then on the RHS, I can put any non-empty subset of the remaining attributes ACD. Similarly, on the LHS, if I put C, then on the RHS, I can put any non-empty subset of the remaining three attributes, which means ABD. Okay, and so on. So very simple. Now you tell me, in this case, okay, tell me, in this case, how many choices for LHS? For LHS, how many choices are there? I want to ask for LHS, how many choices are there? Okay, there are total 4 attributes. From these 4 attributes, you can choose one attribute and you can put here. Okay, from 4 attributes, you can choose one attribute and you can put on LHS. So there are 4 C1 choices. Let me tell you, this concept you might already know. Okay, that if you have n different things, if you have n different items, okay, from these n different items, if you want to choose, if you want to choose, if you want to choose r different items, okay, is this clear? From these n different items, if you want to choose r different items, if you want to choose, then how many ways this you can do in NCR ways? Okay, these many ways are there. Here this C basically means choose. Okay, so from n you can choose r. Is this clear? Okay, very simple. So here you can see that, okay, on LHS I want to put one attribute. So from 4 attributes I can choose one attribute. Okay, from 4 I am choosing one. 4 choose one. Okay, tell me, for for this RHS, how many choices are there? For this RHS, I can put any subset, any non-empty subset of the remaining 3 attributes. So that will be 2 power 3 minus 1. These many choices. Yes or no? Okay. So remember, in case number 1, how many useful FDs I will get? In case number 1, I will get 4C1 multiplied by 2 power 3 minus 1. That is equal to 4 multiplied by 7. These 28 useful FDs I got. Okay, in the case number 1. Is this clear? What about case number 2? Case number 2 means on LHS, I am putting 2 attributes. This is case number 2. Okay, on LHS, I am putting 2 attributes. There are 2 attributes I am putting on LHS. And on RHS, I can put any non-empty subset of the remaining 2 attributes. Okay, so tell me, for LHS, how many choices I have? From 4 attributes, you choose 2 attributes for LHS. Yes or no? From 4, choose 2 attributes for LHS. So there are 4 attributes. From them, choose 2 attributes for LHS. So these many choices are there. For LHS, I have these many choices. What about RHS? Tell me, what about this RHS? Any non-empty subset you can choose from the remaining 2 attributes. So that will be 2 power 2 minus 1. These many choices for RHS. Okay, so tell me, in this case number 2, what answer I got? I got 4C2 multiplied by 2 power 2 minus 1. That is equal to, what is 4C2? Okay, 4C2, that is 6. Yes or no? 4C2 is 6. So 4C2, that is 6 multiplied by 3. So that will be 18 choices, 18 useful FDs. In this case number 2, I got 18 useful FDs. What about case number 3? Tell me, what is case number 3? Case number 3 is I put 3 attributes on the LHS. On LHS, I put 3 attributes. Okay, 3 attributes I will put here. Okay, now on RHS, what I can do? On RHS, I can put any non-empty subset of the remaining 1 attribute. Yes or no? Okay, so for RHS, only 1 choice will be there. Do you agree with me? If I put 3 attributes on the LHS, then only 1 choice will be there for RHS. There will be only 1 choice. That's it. Okay. Now for LHS, how many choices are there? From 4 attributes, I need to choose 3 attributes. Yes or no? From 4, I need to choose 3 attributes. These many choices I have for LHS. Okay. So finally, in this case number 3, what answer I got? I got 4C3 multiplied by 1. 4C3, that is 4. Okay. So these are the 4 useful FDs I got in this case number 3. and no other case is possible. On LHS, can I put 4? If I create case number 4 on LHS, if I put all the 4 attributes, then no useful FD I will get. Yes or no? I will get 0 useful FDs. Yes or no? So finally, what is your answer? Tell me. So finally, the answer will be okay. In case number 1, 28, case number 2, 18, case number 3. So that will be total 50 useful FDs. This will be your answer. This is method number 2. Is this clear? Please tell me. Let me know. This method number 2 is clear to everyone. Very simple. Now let's see the method number 3. That is, if you have n attributes, then how many useful FDs you can create? See, for this question, relation with 4 attributes, total number of possible useful FDs, the answer will be 50. We have already seen. Okay, this is done. This is done. But if the question is about n attribute, if the question is about 6 attribute, 8 attribute, 10 attribute, then what will be the answer? Yes or no? So now I'm going to tell you the method number 3, that is for n attributes. Let's directly find the answer for n attributes. Yes or no? Okay, that will be interesting or not? Please tell me. Do you want to know how to find the answer for n attributes? If you have relation with n attributes, there are total n attributes, A1, A2, and so on, AN. Now, in this case, how many useful FDs are there? That will be our method number 3. Okay, so let's see this method number 3 now. Okay, the idea is very simple. Again, we will create cases. Yes or no? What will be case number 1? Tell me, what will be case number 1? Case number 1 will be when LHS has 1 attribute. If I put on the LHS, if I put 1 attribute, here I am putting 1 attribute. Okay. On RHS, what I can put? Remember, on RHS, I can put any non-empty subset of the remaining n minus 1 attributes. I can put any non-empty subset. Okay. Of remaining n minus 1 attributes. N minus 1 attributes. Okay. Is this clear? So tell me, for LHS, how many choices are there? For LHS, from n, I have to choose 1. On LHS, I want to put 1 attribute. So from n attributes, I want to choose 1 attribute. Okay, from n, I want to choose 1 attribute. Okay, so these many choices for LHS. For RHS, how many choices are there? I can put any subset, any non-empty subset of the remaining n minus 1 attributes. So for RHS, I have 2 power n minus 1 minus 1. These many choices. Yes or no? Is this clear? So in this case number 1, how many useful FDs I got? In this case number 1, how many useful FDs I got? I got NC1. I got NC1 multiplied by 2 power n minus 1 minus 1. These many useful FDs I got. Is this clear? The case number 1 is clear to everyone. Please tell me. Let me know. Now, what is the case number 2? What will be case number 2? Please tell me. Case number 2 means on LHS, I am putting 2 attributes. Okay, remember on the LHS, I will put 2 attributes. Now on the RHS, what I can put? Let me know. On RHS, I can put any non-empty subset of remaining n minus 2 attributes. Yes or no? Again, here I can put any non-empty subset. Any non-empty subset of remaining n minus 2 attributes. Clear? Okay. So tell me, for LHS, how many choices are there? You can see from n attributes, I want to choose 2 attributes for the LHS. Okay, from n, I want to choose 2 for LHS. So that will be NC2 choices. Okay, these many choices for LHS. For RHS, how many choices are there? I can put any non-empty subset of the remaining n minus 2 attributes. So that will be 2 power n minus 2 minus 1. Yes or no? These many choices. Is this clear? So tell me, finally, let me know in this case number 2, how many useful FDs you got? How many useful FDs I got in this case number 2? That will be NC2 multiplied by 2 power n minus 2 minus 1. These many useful FDs I got in this case number 2. Okay. Now what about case number 3? Let me tell you about the case number 3 also. Then we can do the generalization. In the case number 3, what I will do? I will put 3 attributes on the LHS. On the LHS, I will put 3 attributes. On RHS, I can put any non-empty subset. Okay, yes or no? Here I can put any non-empty subset. Any non-empty subset of remaining n minus 3 attributes. Remaining n minus 3 attributes. Yes or no? So tell me, for LHS, how many choices you have? From n attributes, for LHS, you want to choose 3 attributes. From n, you want to choose 3 attributes for LHS. So these many choices for LHS. For RHS, how many choices? You can choose any subset of the remaining n minus 3 attributes, any non-empty subset. Okay, so for RHS, you have 2 power n minus 3 minus 1. These many choices. Okay, so tell me, in this case number 3, how many useful FDs you got? You got NC3 multiplied by 2 power n minus 3 minus 1. These many useful FDs I got. Okay, is this clear? Now, can you see the pattern? Actually, it is happening. See, notice what is happening. Okay, finally, the total number of useful FDs. Let me tell you. Total number of useful FDs, what that will be? Useful FDs. That will be equal to, that is like this. See, in the case number 1, what we got? Notice, in this case number 1, on LHS, we are putting only one attribute. On RHS, we are putting any non-empty subset of the remaining n minus 1 attribute. So the case number 1, that was basically for LHS, one attribute. Okay, on RHS, any non-empty subset of the remaining n minus 1 attributes. This is your case number 1 plus what is case number 2? Case number 2 is on LHS, 2 attributes. On RHS, any non-empty subset of the remaining n minus 2 attributes plus, and so on. Yes or no? Did you notice? This is what is happening. Case number 3, NC3 multiplied by 2 power n minus 3 minus 1. This is case number 3. And so on. If I do, tell me, if I do like this, then ultimately at the last, what I will get? At the last, what I will get? Like this, if I keep doing, then at the last, I will get NC on the LHS. Tell me maximum how many attributes I can put on LHS? On LHS, how many maximum attributes I can put? I can put n minus 1. These many I can put on LHS. Okay, so for the RHS, there will be 2 power 1 minus 1. Okay, these many choices. Is this clear? So like this, actually, let me tell you what is happening. So finally, the total number of FD in this method number 3, we are discussing method number 3. I hope you understood this method so far. Did you understand? Please tell me. Please tell me, did you understand? Total number of useful FDs, that will be equal to, that is like this. See, that is like this. We are doing NC1. Okay, let me tell you what is happening here. NC1 multiplied by, okay, NC1 multiplied by 2 power n minus 1 minus 1 plus NC2 2 power n minus 2 minus 1. Okay, then again plus, and so on. Okay, and so on, you are going like this. Okay, at the end, you will have this value. You will have NC n minus 1. Okay, because on the LHS, you can put n minus 1 attributes. Okay, plus 2 power. See, when I have 1 here, what I am getting here? I am getting n minus 1. When I have 2 here, I am getting n minus 2. So tell me at the end here, what I will get? I will get n minus 1. Minus 1. And that is same as 1. Yes or no? Ultimately, this is only 1. Is this clear? You can see. See, when I have 1 here, I have n minus 1 here. When I have 2 here, I have n minus 2 here. So, and so on. I will get n minus, when I have n minus 1 here, n minus 1. If you check it, this value will become 1. Okay, you can see this value will become 1. Is this clear? So this is your answer. Now let's simplify this. We have to simplify this. But one thing I want to ask you, if I take it till n, okay, for example, just tell me this simple point. You tell me, okay, what is this value? Not if I take it till n, for example, I want to ask you this value. See, if I put n here, then 2 power n minus 1. What is this value? This value actually will become 0. Yes or no? Did you notice? Because this value will become, this will become 1. 2 power 0 is 1. That you already know. 2 power 0 is 1. So actually this value will become 0. So can I add 0? In this, can I add 0? Can I add 0? Yes, I can add 0. Means I can add this. Okay, remember I can add this. So remember what I'm telling you, because this is anywhere 0. See, this value will be 0. Okay, so I can add 0, no problem. So remember my final answer is actually this. Okay, I can write that my final answer is nc1 multiplied by 2 power n minus 1 plus nc2 multiplied by 2 power n minus 2 minus 1. I can take it till n. Okay, because ultimately the final value will become 0. Okay, the final value will anyway become 0. Do you agree? See, I can take it till n, ncn. I can take it till n. Anyway, the final value, that will become 0. That will become 2 power n minus n. Okay, so let me write it clearly. So the final value I can take till n, it will be like this. ncn multiplied by 2 power n minus 1. Okay, remember this value is actually 0. Are you getting my point? See, this was our answer. Okay, from 1, we are starting from 1, then we are starting from 1, then we are going to 2, then 3, and ultimately we are going till n minus 1. But if I go till n, if I go till n, then what I will get? Then I will anyway get 0. So can I add 0? Any value plus 0, that will be same. Okay, so there is no problem. So I can add 0. That is the reason I am going till n. Did you understand why I am going till n? Because anyway this value will become 0. See what I am telling you. Anyway this value will become 0. Okay, so you don't have to worry about it. Okay, so that's it. I hope you understood. Can you write it in the short form? The short form is like this. Summation of, okay, this n is fixed. See here n is fixed. Okay, summation of n c. See, this is not fixed. This is 1, 2, and so on. So I can put r here. This r is going from 1 to n. Okay, yes or no? ncr multiplied by 2 power. What should be the 2 power? Tell me, in the 2 power, what should I write? See, when I have 1 here, then the power of 2 is n minus 1. When I have 2 here, here you have n minus 2. So when I have r here, then you will put n minus r minus 1. Okay, yes or no? This is your final answer. Let me tell you. In the method number 3. In the method number 3, this is your final answer. But can we simplify this? Okay, let's simplify this. Let's simplify this. Okay, now I am going to simplify this. Now finally you will get a very beautiful result you are going to get. Just wait for it. Okay, let's simplify this. This will be summation r is going from 1 to n. Right? R is going from 1 to n. ncr multiplied by 2 power n minus r minus 1. Okay, the same thing, I can multiply this inside this. So can I write it like this, that summation of r equal to 1 to n ncr multiplied by 2 power n minus r minus summation of r equal to 1 to n ncr. Can I write like this? Please tell me. See, very simple. This ncr I am multiplying inside. Yes or no? This ncr, if I multiply with this, minus ncr. Okay, yes or no? Is this clear? Please tell me. So I can write it separately. Do you agree? I can write it separately. Yes or no? Are you getting my point? See, summation 1 to n, this value, okay, this value is here. And similarly, summation 1 to n, this value is here. Okay, is this clear? Now let's see what this value will become. Tell me. Tell me what this value is going to become. See, a very simple thing. I hope you already know that. Tell me what is it? Summation of ncr from r equal to 0 to n. Okay, from r equal to 0 to n. That means nc0 plus nc1 and so on ncn. What is this value? Okay, this value is equal to 2 power n. Okay, this value is equal to 2 power n. Okay, this is a result from the combinatorics. This value is 2 power n. So tell me what value we want. We want what value? See, we want r equal to 1 to n. Okay, we want r equal to 1 to n. Means I want this value. So what this value will become? Okay, so summation r equal to 1 to n ncr. That will become what? This value is anyway, this value is 1. Yes or no? This value is 1. So I will get 2 power n minus 1. This is what I will get. Correct? Okay, so remember, finally, I can say that I got this value has become what? This has become 2 power n minus 1. Is this clear? This value is 2 power n minus 1. Now, what about this value? What about this one? Okay, for this, you already know the binomial theorem. The binomial theorem. See the binomial theorem that you already know, that is a plus b power n. If you don't know, don't worry. In the mathematics, in your school life, in the combinatorics, these things we study. Okay, don't worry if you did not understand this, if you don't understand this, because these things you can study in the permutation, combination, counting, combinatorics. Okay, there you can study. These are very simple things. So this is binomial theorem, a plus b power n. What that will be equal to? This result in your school life, I think you have seen that n c 0 a power 0 b power n plus nc1 a power 1 b power n minus 1 plus nc2 a power 2 b power n minus 2 and so on. ncn a power n b power n minus n means b power 0. Okay, means b power 0. Okay, is this clear? This is the binomial theorem. Now look at this expression. Okay, let's look at this expression. Let's write down this expression. So what you are getting, see, let's look at this summation r equal to 1 to n ncr multiplied by 2 power n minus r. Let's look at this. Let's open it. Or you can easily see. See, can I write it multiplied by 1 power r? Because 1 power r will be 1. Yes or no? Can I write like this? Tell me. Can I write multiplied by 1 power r? Because anyway, this value will be 1. Okay. Now, what result we have? See, remember, this result we already know that if you do from r equal to 0 to n, then the answer I already know. See, you know that summation r equal to 0 to n ncr multiplied by 2 power n minus r multiplied by 1 power r. This value you already know. This is basically 1 plus 2 power n. Okay, this is 1 plus 2 power n. Correct? Okay. But I want this value. So what this value will become? What this value will become? Remember, very simple. See, look at this. Okay, look at this here. This is your binomial theorem. See, in the binomial theorem, if you go from r equal to 0 to n, ncr multiplied by a power r, b power n minus r, this value, if you look at, this value will be basically a plus b power r. Correct? Yes or no? I want to ask you what will be this value. Okay. See, 1 plus 2 power n. Okay. That is actually equal to what? That is actually equal to nc0, 1 power 0, 2 power n. Okay. Yes or no? Plus nc1, 1 power 1, 2 power n minus 1. Yes or no? Agree? Okay. And so on. Plus nc2, 1 power 2, 2 power n minus 2. And so on. ncn, 1 power n, 2 power 0. Correct? Okay, is this clear? And what we want? We want r equal to 1 to n. R equal to 1 to n we want. Okay, r equal to 1 to n means actually this is what we want. This is what we want, right? R equal to 1 to n. This is what I want. Okay, so if I want this, then just find what is this value. Tell me what is this value. nc0 is 1. So this value is 2 power n. Yes or no? This value, if you look at this value, this is 2 power n. This is 2 power n because you can see 1 power 0, that is 1. This is 1. So this is 2 power n. So finally, this value will be what? This value will be what? This value will be, here you have 3 power n. This will be 3 power n minus 2 power n. Is this clear? Anyway, finally I got this value is 3 power n minus 2 power n. Understood? Please tell me. Let me know. Okay, so finally, that's it. This is your method number 3 answer. So in the method number 3, your answer is what? Tell me. In the method number 3, the total number of useful FDs, the total number of useful FDs that will be equal to, that will be 3 power n minus 2 power n minus 2 power n minus 1. Yes or no? 3 power n minus 2 power n minus 2 power n minus 1. So what you got? 3 power n minus double of 2 power n, that is 2 power n plus 1 minus 1 plus 1 plus 1. Okay, plus 1. Is this clear? This is your final answer. We got the formula for n attributes. Now you can easily find for 4 attributes what will be the answer. This is the general formula. Let me tell you. This is what we got. We got the general formula. Is this clear? Let me know. Please tell me, did you understand? So remember, finally remember, this is the note. This is the note that if you have n attributes, A1, A2, and so on, An, if you have n attributes, then how many useful FDs I can create? Total number of useful FDs. Useful FDs, that will be equal to 3 power n minus 2 power n plus 1 plus 1. This is the value. This is the complete analysis of this GATE exam question. I hope you loved it. Please tell me, did you like it? This is the method number 3. You can solve this GATE exam question by 3 methods. This is the final method. This is the general method, and you got this formula. Now you can easily check. If I put n equal to 4, then what will be the answer? If I put number of attributes equal to 4, then am I getting 50? Are we getting 50? 3 power 4 minus 2 power 5 plus 1. That is 81 minus 32 plus 1. That is 50. So the answer will be 50. Yes or no? Is this clear? Now you can solve any question. So this is the final answer. 3 power n minus 2 power n plus 1 plus 1. This is the complete analysis of this GATE exam question. I hope you loved it. Please tell me, did you understand? Let me know. So we have done the complete analysis. So in this question, if you have n attributes, then answer will be for n attributes. For n attributes, the value is 3 power n minus 2 power n plus 1 plus 1. Okay. This is the complete analysis. Clear? Let me know. See, in this question, I want to tell you one thing, that in this question, combinatorics we have used. See, in the method number 1, I did not use any combinatorics. Okay, so the method number 1, that was very easy method for understanding purpose. Okay, did you understand method number 1? In the method number 2, I used small amount of combinatorics, small amount of counting in the method number 2. In the method number 3, a lot of combinatorics I've used. Yes or no? But don't worry, if you did not understand method number 3, then watch counting lectures. Okay, watch permutation, combination, counting lectures, watch. Okay, just this binomial theorem, this permutation, combination, these basic concepts of the combinatorics you watch, and then you can easily watch this method number 3 again. Okay, so this is the final answer. This is the complete analysis of this GATE exam question. Please tell me, did you like it? Let me know. If you are watching this video as a recorded format, please share your feedback in the comments. Did you understand all these methods? Method number 1, 2, 3, and this method number 3. This is the general method. This is the general formula, and I hope you loved it.